Good morning, children. We proceed on miscellaneous problems in chapter 5 based on Gregory Newton's forward interpolation or backward interpolation formula. Question number 3. A second degree polynomial passes through the points. Almost 4 points are given. We need to find the polynomial. Given 4 points, let us create the table. The first values you call x. The second values we call y. Let us create the forward difference table to arrive at the second degree polynomial. Del y. How do we do it? We keep subtracting. 5 minus 1. 1 minus of minus 1. 1 plus 1. Minus 1 plus 1. 5 minus 1. 1 minus of minus 1, minus 1 minus of minus 1. To get del square y, again subtract 4 minus 2. 2 minus 0. To get del cube y, again subtract 2 minus 2. So we have to know how to create the forward difference table. 5 minus 1, 1 minus of minus 1. Minus 1 minus of minus 1. 4 minus 2, 2 minus 0. Again 2 minus 2. Once I have created the table, box the values and call them as y0, del y0, del square y0 and del cube y0. As we fill in y0 minus 1, del y0 0, del square y0 2, del cube y0 0. Once we have found out these values from the forward difference table, let us recall Gregory Newton forward interpolation formula. Y equals y0 plus n by 1 factorial del of y0 plus n into n minus 1 by 2 factorial del square y0 and so on. To find out n, remember x is equal to x0 plus nh, or as I rearrange, n is x minus x0 by h. To get the second degree polynomial, keep x as x itself. x0, the very first value, so it is 1. So this value I call x0. What is h? How does it increase? 1, 2, 3, 4. Each time the spacing is 1. So h is equal to 1. As we substitute, n equals x minus x0 is 1, h is also 1. So we just get n is equal to x minus 1. Substituting in the formula, y equals y0, that is minus 1, plus n is x minus 1 by 1 factorial is 1. Del y0 0 plus n into n minus 1, x minus 1 minus 1. 2 factorial is 1 into 2. Del square y0 is 2. Del cube y0 0. So we just stop the answer with this. As I simplify, it is minus 1. This full term becomes 0. Cancelling 2 and 2, I get x minus 1 into x minus 2. As we multiply, x square minus 2x minus x plus 2. As we simplify, it is x square minus 3x minus 1 plus 2 is plus 1. Y equals x square minus 3x plus 1 is a second degree polynomial passing through the given points. Question number 5. Find f of 0.5 if f of minus 1, f of 0, f of 1, f of 2 are given. To find point 5, which falls between 0 and 1. Point 5 falls between 0 and 1. We can use either forward table or backward table. How to fill up x values from here? Minus 1, 0, 1, 2. What are y values? The RHS values. 202, 175, 82, 55. To create the table, let us subtract 55 minus 82. 82 minus 175. 175 minus 202. Same way, let us subtract minus 27 plus 93. Minus 93 plus 27. Del cube y 66 plus 66. As we have completed the table, we will box the first and call them as y0, del y0, del square y0, del cube y0. So as we write the values, y0, del y0, del square y0, del cube y0. As we know the values, let us write down Newton-Gregory forward interpolation formula. Y equals y0 plus n by 1 factorial del y0. n minus 1 by 2 factorial del square y0 plus n minus 1, n minus 2 by 3 factorial into del cube y0 and so on. What is x? It is x0 plus nh, or I can rewrite n is equal to x minus x0 by h. X, the given question, that is 0.5 minus x0. The very first value we call x0. This value we call x. X0 is minus 1 divided by h, the equal spacing. Minus 1 to 0, 0 to 1, 1 to 2. 1 by 1 it is increasing. H is equal to 1. As we simplify, it is 0.5 plus 1, that is 1.5. Let us substitute in y. y0, that is 202 plus n value by 1 factorial del y0 plus n into n minus 1 by 2 factorial into del square y0 plus n into n minus 1 into n minus 2 by 3 factorial into del cube y0. 202, 1.5 into minus 27, 1.5 into 0.5 into minus 66 by 2, 1.5, 1.5 minus 1, 1.5 minus 2, 132 by 2 into 3. As we multiply it all, these three together gives me 136.75 and this 8.25. As we subtract, we get 128.50. My question is f of 0.5, which is 128.5, and that completes the answer. Question number 6. Find y when x is equal to 43 and 84. 43 falls between 40 and 50, whereas 84 falls between 80 and 90. So given the data, we need to calculate forward difference table and the interpolation formula. Then backward difference table and the interpolation formula. As we create the forward difference table, copy x values 40, 50, 60, 70, 80, 90. The interval is spaced with 10 and uniformly increasing. Y values 184, 204, 226, 215, 276, 304. So the given table we have copied. Calculating forward difference table. 304 minus 276. 276 minus 250. 250 minus 226. 226 minus 204. 204 minus 184. Del square y, 28 minus 26. 26 minus 24. 24 minus 22. 22 minus 20. Del cube, 2 minus 2. 2 minus 2. 2 minus 2. Del power 4, 0 minus 0, 0 minus 0. Del power 5, 0 minus 0. Most of the values are 0 for us to calculate easily. As I look at the table, let me box the very first values for y0, del y0, del square y0, del cube y0 up to del power 5 y0 we can write. So the values, let us tabulate. y0, del y0, del square y0, del cube y0, del power 4 y0, del power 5 y0. As we recall the interpolation formula by Newton Gregory. Find out x. What is the formula? It is x0 plus nh. Or I can write n is equal to x minus x0 by h. In this question, x is the given question, that is 43. x0, the very first value, that is 40. h, the equal spacing, 10, 10, it is increasing. So it is 43 minus 43 by 10, or I can write 0.3. As we substitute in the formula, y equals y0, the value 184, plus n value 0.3 into del y0, 20 by 1 factorial, n into n minus 1, 0.3 into 0.3 minus 1 by 2 factorial, del square y0, plus n into n minus 1 into n minus 2 by 3 factorial into del square y0 over del cube y0. So the remaining are 0. I can just ignore. As I simplify, it is 184 plus 20 into 0.3 plus this 2 and 2 cancels, 0.3. 0.3 minus 1 minus 0.7. 184 plus 6, 190 minus 0.3 into 0.7, 0.21. As we subtract, 189.79, and that is the answer. To find out y when x is equal to 84, we need to look at the table, but now we will mark the backward values. Call them as y0, y1, y2, y3, y4, y5. So y5, nebula y5, nebula square y5, nebula cube y5, nebula power 4 y5, and nebula power 5 y5. It's good if we write the table again. Otherwise, the same table but mark these values as nebula values, whereas these values we call delta values. So this is y0, delta y0, delta square y0, delta cube y0, delta power 4 y0, and delta power 5 y0. As we recall, what is n when it is backward interpolation? n is equal to x minus xn by h. As we look at the table, the very first value we call x0 of x, and the last value we call xn. As I substitute, x is equal to the given question, that is 84. xn is equal to 90 from here, h, the equal spacing, that is 10. As we simplify, 84 minus 90 minus 6. When I divide by 10, it is minus 0.6. As we substitute in the backward formula, y5 304. N value minus 0.6. 1 factorial is 1. Nebula y5 28. N into minus 0.6 minus 0.6 plus 1. 2 factorial is 1 into 2. Nebula square y5 is 2. All the remaining values are zeros. So we just put plus 0. As we use calculator and simplify, it is 304 minus 0.6 into 28. Minus 16.8. Minus 0.6. 1 minus 0.6 is 0.4. 2 and 2 I can cancel. As we simplify, we get 286.96. Take and write the answer. Question number 7. Given diameter D and area A of the circle. Find the area when the diameter is 82 and 91. 82 falls in the first interval, whereas 91 falls in the third interval. So we can use forward difference table for 82 and backward for 91. As we create the difference table, 7854 minus 7088, 7088 minus 6362, as I keep on subtracting. 766 minus 726, 726 minus 688, 688 minus 648. 40 minus 38, 38 minus 40. Let us be careful with the plus or minus symbol. 2 minus of minus 2 is plus 4. As we have completed the table, let us highlight y0, del y0, del square y0, del cube y0 and take and write the values. Y0 is 5026, del Y0 648, del square Y0 40, del cube Y0 minus 2, del power 4 Y0 is 4. As we recall the formula, Newton-Gregory for forward interpolation, we know x is equal to x0 plus nh, or we rewrite n is equal to x minus x0 by h. In this problem, x, the value given in the question, that is 82. x0, the very first value of x, that is 80. H, the equal spacing 5, 5, it is increasing, so it is 5. 2 by 5 or I get 0.4. Once I know n value, that is 0.4. Find out n minus 1. 0.4 minus 1, that is minus 0.6. Find out n minus 2. 0.4 minus 2, that is minus 1.6. Find out n minus 3. 0.4 minus 3, that is minus 2.6. As we substitute these values in the formula, y equals y0 5026 plus n value by 1 factorial del y0 plus n value, n minus 1 value by 2 factorial into del square y0 plus n value, n minus 1, n minus 2 by 3 factorial is 1 into 2 into 3 del cube y0 plus n, n minus 1, n minus 2, n minus 3 by 4 factorial into del power 4, that is 4. As we multiply using calculator and simplify, we get 5026 plus 259.2 minus 4.8 minus 0.128 minus 0.1664. That reduces to 5280.10, approximately 5281. When x is equal to 91, we need to write backward difference table. So, marking the last values of the table, we call this as y, y0, y1, y2, y3, y4. This will be nabla y4, nabla square y4, nabla cube y4, nabla power 4 y4. So let us write down the values. y4 is 7854. Nabla y4 766. Nabla square y4 40. Nabla cube y4 2. Nabla power 4 y4 is 4. Remember what is x is equal to? xn plus nh. N is equal to x minus xn divided by h. Here x value 91. xn, the last value of x we call xn, that is 100, divided by h, the equal spacing, so it goes 5 increased. My answer minus 9 by 5, or I will say minus 1.8. As we have found n value, let us find out n plus 1, n plus 2, n plus 3, as we need to substitute in the backward interpolation formula. Y is equal to y4. The starting value 7854 plus n value minus 1.8. 1 factorial 1. Nebula y4 766 plus n into n plus 1 minus 1.8 into minus 0.8 by 2 factorial nebula square y4, that is 40, plus n into n plus 1 into n plus 2 divided by 3 factorial into nebula cube y4, that is 2, plus n into n plus 1 into n plus 2 into n plus 3 divided by 1, 2, 3, 4. Nebula power 4, that is 4. As we use calculator and simplify. 7854 minus 1.8 into 766 minus into minus plus 1.8 into 0.8 into 40 by 2 minus into minus plus 1.8 into 0.8 into 0.2 into 2 by 1 into 2 into 3. Again minus into minus plus, multiply it all, divide by 1, 2, 3, 4. Simplifying which we get 6504.15. So the area is approximately 6504. Let us take and write the answer. When diameter is 82, area is 5281. And when the diameter is 91, area is 6504, and that completes the answer. Question number 9. Obtain a polynomial of degree y in x. Given a table with x and y values, let us create the forward difference table so that we can use Newton-Gregory interpolation formula to create the polynomial. For forward difference table, copy x, y values 1, 2, 3, 4, 5. Y values 1, minus 1, 1, minus 1, 1. Let us find out del y. As we subtract 1 plus 1, minus 1, minus 1, 1 plus 1, minus 1 minus 1. Find out del square y. 2 plus 2 minus 2 minus 2, 2 plus 2. Del cube y. 4 plus 4 minus 4 minus 4. Del power 4y. 8 plus 8, 16. Let us write down the forward values. As we box around, we call these values as y0, del y0, del square y0, del cube y0 and del power 4 y0. Y0 is 1, del y0 minus 2, del square y0 4, del cube y0 minus 8, del power 4 y0 is 16. To get the polynomial, we write x is equal to x itself. In the formula, x is equal to x naught plus nh, or n is equal to x minus x naught by h. In this question, x is x itself, x naught. The very first value we call x naught, that is 1. H, the equal spacing, it increases by 1. So h is 1. As we recall Gregory Newton's formula, y equals y naught plus n by 1 factorial del y naught, n into n minus 1 by 2 factorial del square y naught, n into n minus 1 into n minus 2 by 3 factorial del cube y naught, plus n minus 1, n minus 2, n minus 3 by 4 factorial del power 4 y naught, and so on. As I substitute, what is n? It is x minus 1. What is n minus 1? X minus 1 minus 1 or x minus 2. What is n minus 2? X minus 1 minus 2, that is x minus 3. And what is n minus 3? X minus 1 minus 3, that is x minus 4. Let us substitute these values in the formula. Y equals y naught is 1 plus n value by 1 factorial del y naught, that is minus 2, plus n into x minus 1 into n minus 1 x minus 2 divided by 2 factorial del square y naught, that is 4, plus n into n minus 1 n minus 2 by 3 factorial 1 into 2 into 3 del cube y naught is minus 8, plus n into n minus 1 into n minus 2 into n minus 3 divided by 4 factorial into del power 4 y naught. As we simplify, y equals 1 minus 2 into x minus 1. I can write minus 2x plus 2 plus. In all these terms, what is common? Let us take out this term and this term. I have x minus 1 into x minus 2. As I simplify, it is 2 in the first term. As I cancel, minus 4 by 3 into x minus 3. As we cancel here, 2 4s are 8 plus 2 by 3. X minus 1, x minus 2 taken out, remaining x minus 3 into x minus 4. Let us take LCM and simplify the problem. X minus 1 into x minus 2. X square minus x minus 2x plus 2. Here if I take LCM 3. 2 3s are 6 minus 4 into x minus 4 into minus 3 plus 2 into x minus 3 x minus 4. As I multiply x into x minus 3x minus 4x plus 12. Y equals 1 plus 2 3 minus 2x plus x square minus 3x plus 2 into 6 plus 12 18 minus 4x 2 into x square 2 into minus 3x minus 4x minus 7x into 2 minus 14x. 2 12s are 24. The whole thing divided by 3. 2x square minus 4x minus 14x minus 18x. 18 plus 24 42. The whole thing divided by 3. As we simplify further, y equals 3 minus 2x plus. Bring 3 out. Let us multiply. X square into 2x square. X square into 18x. X square into 42. Minus 3x into 2x square. Minus 3x into minus 18x. Minus 3x into 42. 2 into 2x square. 2 into 18x. 2 into 42. As we take LCM 3. 3 into 3 9 minus 3 2s are 6 plus the remaining as we simplify 2x power 4 minus 18x cube minus 6x cube together minus 24x cube 42x square 54x square 4x square together 100x square minus 126x minus 36x together minus 162x and the constant here 84. As we put the whole thing divided by 3, we get the final answer. Y is equal to 2x power 4 by 3. (24x cube by 3 is minus 8x cube. 100x square by 3 cannot simplify, write as it is. 100x square by 3. Minus 162x minus 6x together minus 168x divided by 3. We get minus 56x. 84 plus 9, 93. As we divide by 3, it is 31. And so we have obtained the required polynomial.